Hey guys, this is Daniel. We'll be continuing from where we stopped. We'll continue from where we stopped in set notation. Okay, we'll be talking about finite and infinite sets. Okay, so first of all, infinite sets is a set whose number of elements cannot be counted, right? So in infinite sets, such sets are sets that cannot be counted, right? So if we have set A to be 1, 2, 3, 4, 5, and then we're having 3 dots, right? This means that this set is an infinite set, right? And this 3 dots is called ellipses. Okay, it's called ellipses. So ellipses can be used before the elements in a set and also after the elements, right, to indicate continuity. Okay, so for example, if we have a set of positive whole numbers, we know that if we should count positive whole numbers, it's going to take a lot of time. In fact, we can't count positive whole numbers, right? Because it's going to take forever, or let me say it is uncountable, right? So because it is uncountable, we are going to be using the ellipses to signify continuity. Okay, while finite set is a set that contains a restricted number of elements. Okay, so in finite sets, we know the beginning and we know the end. All right, such as a set A equal 1, 2, 3, 4. Right, so this is an example of a finite set. Okay, so now let's move to the fourth one, which is subset and superset. Subset and superset. Okay, so given a let me say given two sets A and B. Okay, if we are given two sets A and B such that all the elements in B are contained in A. Okay, I want you to listen carefully. If we are given a set A, if we are given two sets, right, A and B, such that all the elements in B are contained in A. So this means that B is called the subset of A because all the elements in B can be found in A. Okay, so B is a subset of A. All right, I think we are clear with that. Maybe I should write it out. So given two sets A and B, such that all the elements in B, all the elements in B are contained in A. Right? So therefore, B is called a subset of A, right? And it is written as B a subset is written this way of A. So B a subset of A. Or you can write it this way, B a subset of A. So if you see something like this, right, it's the same as this. Okay, so it's still talking about subset. All right. So what if B is not a subset of A? Okay. What if B is not a subset of A? Then that means that B is a superset, or let me say A is a superset of B, right? B, remember I said B is a subset of A, okay? So which means that A will be a superset of B, right? So this means that all the elements of B was gotten from, or was derived from, the elements of A. So definitely A is a superset, right, which B was derived from. So B is a subset while A is a superset. Okay, so if B is not a subset of A, it can be written this way: B not a subset of A. Okay, it can be written this way. Now, for A being a superset of B, A is a superset of B, which is written as A B. So which is written as a superset of B. So you can see that subset is facing this way, while if it is for superset, it is facing this way. Okay, so you should get used to it. All right. So, and if B is not a subset of A, then it will have a bar in between, right? Okay, so for example, if we have A equal 2, 3, 4, 5, and B equal 3 and 4. Okay, here we can see that A has 2, 3, 4, 5, and B is 3, 4, right? So 3, 4 can also be found in set A, right? So which means that B is a subset of A, is that not? So therefore I can now say that what B, right, is a subset, to write this well, of A, right? Or I can say A is a superset of B. I think that's clear enough. All right, on to the next. Let's look at power set. Okay, that's number 5. Power set. Okay, so power set gives the total number of a subset, or gives the total number of subsets that can be got from any given set. So power set gives the total total number of subset that can be got from any given set. So power set is talking about finding the total number of sets, right, that can be derived from a particular set. Okay, so and if let's say that we are given a set A. Okay, so if we are given a set A, right, so the power set of A will be written as P A. You can see the way I wrote it. The P is more like a subscript, right? A equal 2 raised to power n. Okay, where n is equal number of elements in the set. So n is the number of elements present in that set. Okay, I think we are good. Now let's take an example. Let us find example. Find the number of subsets in the following. In the following sets and list them. Okay, so we are asked to find the number of subsets in the following sets and list them. So we are not stopping at just finding the number of subsets, we are also listing them. Okay, so number 1, I have A equal an empty set. Number 2, I have B equal 4. 3, C equal 2, 7. 4, D equal A, B, C. And 5, E equal theta, phi, no, and rho. Okay, this shouldn't sound scary. It's very, very simple. Okay, so now let's solve this. Okay, so number 1, to find the subscript of A, remember that the power set is to find the subset, right? Rather, is to find the subset of a given set, right? To find the number of subsets. So power set of A, right, equal 2 raised to power n. So, and we know that n is what? The number of what? Elements. So we don't have any element in this set because it is an empty set. So that means that the number of elements is equal 0. So therefore, I can say that what? Power set, okay, of A is equal to 2 raised to power 0. So, and we know that 2 raised to power 0 is equal what? 1. Right? So, according to the zero index law of indices, right? Okay. So here, now that we've gotten the power set of A, now we can list it out, right? So this power set is now saying that the only subset we can find in set A is 1, just one subset, right? So, and if we are listing that subset out, that subset will be what? Just an empty set. Now let me now explain this, that if you are listing out a subset in the power set, right? If you are listing out a subset, you are going to be starting with an empty set, right? Then before you now list out the members of that set, right? So because an empty set is also a member of a given set, right? So we are going to be listing out you are going to first list out an empty set before you start listing out the members of the set. Okay, so now let's try B for better understanding. Let's try number 2, which says B equal 4. So here, power set of B, that which is equal to 2 raised to power n, right? N is equal, we have just one member, right? So we have just one element. So 1, then power set B equal 2 raised to power 1. So 2 raised to power 1 is what? 2. Okay, so which means that we are supposed to have two subsets from set B. Okay, so listing out this set, right, that will be what? An empty set first. Remember, you first list out an empty set before listing out any other member of the set. Okay, so comma, then we have 4 abi as the element, so 4, and that's all, right? So